To start with, set up the problem with a nice clear diagram. I've chosen a positive direction. You'll notice that although the two particles are moving towards each other, on my diagram I prefer to put the arrow of the 3m mass towards the right and simply write minus u. You'll also notice that I have both of my particles, perhaps at first sight, aiming in the same direction after the impact, when in fact we know that 2m1 has been reversed in direction. Well, you'll notice I'm working with vectors here, so in order to get the inequality that we require at the end, it's much easier to do this and then to make the claim that in fact A is going to be less than 0 because the direction is reversed, and that will lead us to a nice neat solution. So first of all we use momentum, so momentum before the collision is equal to the momentum afterwards. So I've written that down quite neatly, use some brackets, taking care with signs, and that will simplify out to give me a very simple equation. I'm now going to do the same, well not the same, I'm now going to create an equation for restitution. And the general technique here really is to create two equations and solve them simultaneously to find one of the missing variables. Okay, so I start with my preferred version of Newton's law of restitution, which simplifies to give me equation 2 b minus a equals 3u Now I want to really find the value or an expression for a, and then I'll set that less than 0 and the problem should be solved. In other words, I want to eliminate b, so the best thing is to multiply equation 2 by 3 to give me this expression, and then you should be able to see that if I subtract either 1 from 3 or 3 from 1, then the 3b parts will cancel. Okay, so I've done that and I've tied it up a little bit. Just check carefully at this point that you follow the algebra. I've solved this for a because now I can say that a is less than 0, which gives me this inequality to solve. Obviously I can divide each side by u and multiply each side by 5, which leads me to 1 minus 9e is less than 0, so 1 has got to be less than 9e, and therefore e itself must be greater than a ninth. Now for a complete solution I should really state that therefore e lies within the range of values as shown, greater than a ninth and less than or equal to 1.